Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on permutations. We have to find out all the possible permutation, that is all the permutations from a given array. Okay, let's jump into the problem statement, understand it and start solving. So last time we have solved the combination problem, that is on combination sum. Today let's start with permutation. You can find the combination sum in the list. Okay, given an array nums of distinct integer, written all the possible permutations, you can return the answer in any order. Okay, so they have example as well, 1 2 3. We have to return all the permutations. I'm sure everyone is aware of what is permutation combinations. So this is permutation, you can understand it from the example. We have 1 2 3, all the different ways in which you can arrange this. So 1 2 3, 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1, right? We are rearranging them in all the possibilities such that the sequence is not the same. Okay, now similar problem we have solved for combination last time, so we'll use the same approach of backtrack. Okay, now there are few things we have to keep in mind. If you see, so let's I would suggest take a minute and think of the approach before I go on and code. Ready? Okay, so let's say we have this input 1 2 3, right? I have to find out all the combinations. I know I can use the backtrack, and how we are going to solve it using the backtrack I'll discuss in a minute. But what are the edge cases that we should consider? One thing is, we cannot use any of the number more than once, right? So we can use a boolean array to keep track of which all numbers have already been used, right? So if a number has already been used, we can simply skip for it, right? Do we see any other possibility where we can skip? I don't think so. See, as similar to the combination problem here, since we have to arrange 3 places, the moment our combination length reaches 3, we can add it to the result list, right? So what we can do is we'll keep let's say variables for current combination, current permutation. We'll keep a list for the result. If the current permutation at any given point in time reaches the length 3, we'll add it to the result. Similarly, let's say how we form the solution with backtrack. Okay, we start with 1, we add it to our current solution, current permutation. Okay, 1, then we recursively call this, and now the length has reduced. We only have 2 more places to add. We check again, traverse 1 2 3, we check for 1. Now 1 has already been added, that means we need a variable that showcases that 1 was already used. Okay, so we'll skip for 1, we'll go for 2, we'll add 2 to it. Again we'll call for 1 2 3, our length has still not reached the target length of 3, so we'll try to add 1. 1 has been used, 2 has been used, 3 hasn't been used, so we get 3. Now the moment this is done, we add it to the current result. Now as we saw from our earlier video on combinations, once in backtrack, once we have added the solution, we remove the last candidate or the last number integer and backtrack. So we again remove 3, 1 and 2 are left. Okay, now we need a third member. We again go for 1 2 3, 1 is already added, 2 is already added. For 3 we have already backtracked from 3, right? So we cannot go in that direction, so we go one place back again, so we remove 2 also. Now since we backtracked from 2, we'll take 3, we took 3. Again we go for 1 2 3, we check 1 that is already used in our current permutation, 2 hasn't been used, so we pick 2. Now the moment this length is equal to 3, we add it to the result list, and again we backtrack, so we remove the last number, that is 2, we go 1 and 3. Now since we already backtracked from 2, we can add 3, but 3 is already part of it, so we backtrack from that as well, so we backtrack from 3 also. Okay, now for 1 we already covered the path 1 2 3 and 1 3 2, so we have to backtrack this one as well. in the final recursions. So it would happen that recursively we are internally calling recursions after recursions, right? When we are backtracking, we are coming out of all those closure loops. So we came out of the loop of 1 2 3, then 1 3 2 1, 1 3 2, then we move from I equal to 1 to next index, that is 2. So we start with 2. Again we go for 1 2 3. We can add 1. Yes, we can add 1. So we add 1. Can we add 2? We cannot add 2 since 2 has already been used. So can we add 3? We can add 3. We add 3. And similarly, the moment this length reaches the required length, that is the 3, since for the combination all the length will be 3, or for permutation all the length would be 3. So we add it to the result. Then we remove the last candidate, which was 3. Right? This way performing will go from 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1. Okay, now let's start coding and you'll understand it much better. Okay, let's start. So first let's create the result list that we need, which is list of integer. Result is equal to new array list. Okay, then we need another list of integer to keep track of our current permutation combination. Current permutation, okay, is equal to new array list. Okay, now boolean, we need an array to know that which all integers have been used in this current permutation, is equal to new boolean nums dot length. Right? Okay, now we'll use a separate method for doing the backtrack. So we'll call private void backtrack. What all will we pass? We'll pass the provided nums. So int nums will provide the boolean used. Okay, now oops, yeah, no. Okay, we need the current permutation and the result as well, right? So we'll say list of integer, which is current permutation, and then list of integer, that is result. Okay, so in this one here we'll simply call this backtrack method, or we'll comment it, start the backtrack process like we did, backtracking process. So we can say backtrack, pass nums used, current permutation, and result. Okay, return result. Okay, now let's start solving this one. We need the base case. Okay, we know what the base case is, we already discussed. Let me just write it. If the current permutation size equals the array length, that means we have found one permutation. Add this to the result. So we can say if current permutation dot size is equal to nums dot length, we'll say result dot add new array list, and we'll pass current permutation. Okay, and then we can return. Now, right, because once we have found 1 2 3, as we discussed earlier, the current permutation size would have reached 3, that is the array length. We can simply add it to the result list and return from this loop. Otherwise, we are going to iterate through the complete array. So we'll say iterate through the array. or array elements. Okay, for int I is equal to 0, I is less than nums dot length. Please pay attention that we are iterating through all the elements starting from the 0th index to the last index, I plus plus. Okay, now we'll skip for the elements that have already been used. So skip elements that have been used. So we'll check if used of I, then continue. Okay, otherwise we'll include it in the current permutation. So we can say include the current element in the permutation. Okay, so current permutation dot add nums of I, and this will increase the current permutation length. And once we add any element, we'll mark it used. Used of I is equal to true. That's it, right? Now recursively we'll call the backtracking method again. So recursively backtrack with the updated length, updated state. Okay, because now the length is also updated. So we can say backtrack nums. Nothing has changed in nums array. Used, yes, the use combination has changed in the nums array, right? Current permutation, so length of current permutation has increased by 1, and result list, right? And as we discussed for backtrack, once the one complete permutation has been found, we have added to the result list, we'll remove the last element so that we can go for next possible combination. So we'll say remove the last added element to backtrack. That would be current permutation dot remove current permutation dot size. I'm thinking I might get some typos in this one, and then used of I will be marked false again, right? Because we'll remove 3, so we'll mark it false. Okay, yeah, that's it. Let's run it. See, I did get some. 14, line number 14, INTEGER, integer. Is there anything else? No. Okay, right, it's working. Let's run. Let's submit and check. 94.37, great. Okay, the problem on permutation and combination, for both of them we have used the backtrack. Please go through, I would suggest go through this permutation video, also go through the combination sums video from the list and understand the backtrack. Okay, this is very frequently used piece of code in lot of problem solving when we come to backtracking. Okay, that's it from today's video, everyone. For anything else, please let me know in the comment section. At the end, please like, share and subscribe. Thank you.